All right, so for today, we're going to talk about what's called the fundamental theorem of algebra, bless you. And this just pertains to the number of zeros that your polynomial is going to contain. As you guys know from the work you did yesterday in your quizzes, if you had a polynomial of degree 3, how many answers did you get from that? Remember, just 3. Same thing when you had a quadratic, you're going to get those 2 zeros. So what we're going to look at today is what happens when a polynomial has a 0 in the complex numbers. So this is going to pertain to your a plus bi, which means your imaginary is going to come back, as well as we're going to do a couple that have irrational roots. So complex, we're going to do the a plus bi, and we're also going to do some with irrational roots. So these two cases right here. So to begin, you can always take a polynomial and factor it. That's what you've been working with this week. So your first one here, this would just be linear. And if I want to factor 2x minus 4, I would GCF the 2 out, and I would be left with x minus 2. My next one, does it have a GCF? Yep, excellent. 3, she's right. So this is quadratic. So I would take out a 3. I would factor this into x squared minus 5x plus 6. And when you factor, you always want to factor completely. You're going to take it one more step. Trinomial factoring. Multiplies to 6 adds to negative 5 would be x minus 2 and x minus 3. Okay, so that's really what you've seen to this point. So now we're going to see roots that are complex and irrational instead. So if you have a plus bi is a 0, then automatically what's going to happen is that a minus bi will also be a 0. So these always come in pairs. The same thing is true if you have irrational zeros. So a plus bi, if that's a 0, then you're always going to have the a minus b radical c is also a 0. So again, they come in pairs. So if you have one, you can immediately write the other. So anytime it's complex or irrational. So here's your first one. So find the polynomial, bless you, function of degree 3 in standard form, just like you did on your quiz, with the given numbers as zeros. So this one is all taken care of for you already. So the first thing you do is you write this in factored form, just like you did yesterday. So to write this in factored form, you're going to take all of your signs and you're going to flip them. So I'm going to go factored form. So polynomial, let's go p of x equals. And you're going to start flipping your signs. So the opposite of minus 1 would be x plus 1. Yep. So that one's taken care of. Now the one with the 0, you can write x plus 0, but it's really unnecessary. So I just take this 0 and I always just put an x right here in the front for that one. Okay, that's the easiest way to do it. And then my positive 4 is going to become a negative 4. Yep. So now you're going to do the same thing you did yesterday. So this one's just a nice review. And I'm going to multiply this through. So I would have p of x equal to, let's do these two first. So binomial times binomial. So I am going to FOIL all of that out. So I have here x times x, which is x squared. I have x times negative 4, which is negative 4x. I'll just make a little note over here. And then I have 1 times x, which is 1x. So combine those together, and that gets me negative 3x. And then lastly, I do 1 times the negative 4, which gets me minus 4. Almost done. The last thing you're going to do is take this and distribute it through. So my answer in standard form is p of x is equal to, so distribute, I get x cubed minus the 3x squared and minus the 4x. And again, this is what we call standard form. It just means you expand it up. But that is no different than what you've been working with this week. That one's still okay? Okay. And if you want to use box numbers, you can. Number 2, I'm going to come back to. Don't wait and flip. I want to do this one first. So number 4. It says to find a polynomial function of degree 3. It has zeros, 1, 3i, and negative 3i. So this looks different. This has 2 zeros in the complex numbers. So these are your complex imaginary numbers. And they always come in pairs like that. So you're going to start this the same exact way. So to do factor form, I go P of x equals. And I'm still going to just switch my sign. So I go x minus 1. And then I go x minus 3i. And then the last one would say x plus 3i. So conceptually, it's no different. Now, when you go to multiply these out, the easiest thing to suggest is to multiply 2 complex zeros at once. So I think it's easiest to start with these because what you'll find is you'll have some terms that cancel. So I have a P of x equal to. I'm going to leave the x minus 1 for a minute. And now we're going to multiply this out. So I need to do here x times x, which is x squared. I'm going to do x times 3i, which is 3xi. And then I'm going to do negative 3i times x, which is going to give me negative 3xi. So guys, what happens with those? Yeah, they cancel. I'm not even going to write them. So those are gone. And then my last term, I'm going to do negative 3 times positive 3, which is minus 9. And do we remember this part? What is I times I? I squared. And if you remember back, we did something with that. So from unit 2, or you can use your calculator, what did we replace I squared with? You remember? Negative 1, excellent. Okay, so then I'm just going to put that in. So I have P of x equals x minus 1, and then x squared minus 9 times negative 1. So therefore, P of x would simplify in factored form to x minus 1 and x squared plus 9. And you've got just a little bit of multiplication left to do. So lastly, I multiply those 2 binomials, and then you're done. So I get a P of x here equal to x times x squared would be x cubed. Then I'm going to go x times the 9, so that would be 9x. And then I'm going to go negative 1 times x squared, which is negative x squared. And then lastly, negative 1 times 9, which would be negative 9. You're almost done. What do you have to do with 2 of those terms? Yeah, invert them. So flip them around, keep them in standard form. So answer. P of x is equal to x cubed minus x squared plus 9x minus 9. Okay, so you'll see you don't have any i's left over in your answer. So you should see that those go away. Is that one okay? So again, all you do is just take your signs and flip them. So the last one I want to do, and then I'll give you some time to start these, is backwards. I want to do number 2. Number 2 is harder. Why? Because your term that has the I in it has 2 parts to it. Okay? So immediately what I would like you to do is I want you to put a parenthesis around this because we got to keep these together. And then a parenthesis around this one. And then a parenthesis around this one. And a parenthesis around this one. So when you go to subtract it, you've got to include that parenthesis. So I'm going to start this. This is negative 1, so I'm going to start with that and flip my side. So P of x is equal to x plus 1. So that's the one you know how to do already. And then what I'm going to do is I'm going to look at this positive 1 right here, and I'm going to flip the sign. So I'm going to go x minus, and then place it inside with the parenthesis for a minute. And I'm going to do the same thing for the other one. X, and it's minus because I always do the opposite sign. And I'm going to place in there 1 minus 4i. Always work with the two that look the most similar. So I'm going to work with the two complex zeros. So I'm going to right now just do a little distribution underneath this. So this would give me x minus 1 minus the 4i, right? Nice and neat because you're going to have to multiply these out in a second. And then that would be x minus 1 plus 4i. And what's always going to happen with these is terms are going to cancel. So go slow and expect a lot of things to go away. So I still have this x plus 1 here. All right, so we have x plus 1. And now I'm going to multiply. So to begin, I do x times x here. So x times x is x squared. X times -1 is negative x. And then x distributed to the 4i is plus 4xi. Okay, so the first term's done. Now I go to the -1, and the -1 goes everywhere. So -1 times x is minus x. -1 times -1 is positive 1. And then -1 times 4i is minus 4i. And then last. So now I'm going to take the -4i and distribute it to all three as well. So -4i times the x would be -4xi, right, nice and neat. And then -4i times -1 would be plus 4i. And then the last one, please be careful. -4i times positive 4i would be minus 16i squared. So we're going to do it just like that last problem. So first, do you guys notice anything that goes away here? Should be a bunch. Perfect. She's right. That goes away. That goes away. How about the 4xi and -4xi? That goes away. That's always going to happen with these. I think that's it. Yep. So then over here, I squared is -1. So -16 times -1 means that this is 16 back here. So if I continue this, I would have 16 plus 1, so 17, minus 2x, and then x squared. So I have x squared minus 2x plus 17 that resulted from that, multiplied by x plus 1. Okay, if you've done these correct, you're going to see all the i's go away. Last thing I do is distribute, and then we're done. So I have p of x equals. And again, this is why I tend to steer students away from box method, because box method, when you have to do it multiple times in a problem, it gets very, very lengthy. It's much quicker to just distribute quick. So I go x times x squared is x cubed. X times -2x is -2x squared. And then plus 17x. And then lastly, I take the 1 to everything. So 1 times x squared is x squared. Minus the 2x plus the 17. And then you're going to combine like terms. Okay, the final answer. I have p of x equal to x cubed minus x squared plus 15x and plus 17. Okay, how do we feel with those three examples? Are those okay? Okay, I want to give you time to work and I want to cross some things off. So if you flip over to your problem set, You are only required to do number 1 through 3 and 6. So if you'd like, you can just do problems 1, 2, 3, and 6. But again, make sure you are taking these all the way to standard form. All right, you are more than welcome to work together. You are here, shortened schedule until 8:09. Perfect. So you've got about 15 minutes to get a great start on those, okay?